tech lead at Wix. At Wix, if you heard about us, we usually write tests, and other than that, we have some more business that we do. But this is our main objective, to write more and more tests. So let's start with the topic at hand. I'm going to talk about how to refactor and clean tests. And the reason that I'm talking about it is usually if you write tests and if you write TDD style tests, then every time the loop goes, you write the test, you write the failing test, you write the code, then you make the test pass, and then you refactor the code, you make it clean, you make it nice, and then you're off to the next feature. So sometimes you forget to clean the tests themselves, because the tests themselves needs even more attention than the real code. And the reason that I'm saying that is that because tests actually last more than production code. If you deleted production code, you'll know that the last thing that you'll delete is usually the tests. Sometimes you'll rewrite if you wrote a good test and you want to change the implementation, you will actually drop some of your production code, rewrite it, write it with a different technology or everything, and basically the test can stay the same because it just guards the functionality or the behavior of the code. Another thing is tests you have a lot more code than production code. Some people say, I had one person in Wix that said for each line of code, he had 9 lines of tests, which is by far, you have a much more amount of code to maintain, which makes it more important to clean them. And the last thing is that when you write a new feature, and the feature break, then you go back to the test and try to understand why that feature broke. And you'll basically keep reading read those lines of code over and over again. And if they are more coherent, then it's going to be easier for you to later on progress. One of the things that we can talk about when we talk about maintaining tests, that if the tests are badly written and it's very difficult for you to understand them, then you're basically back to square one, because when you want to add a new feature, then and you cannot understand what the test why old features are breaking, then you end up not being able to add that new feature. One of the things that one of the people that I can quote that talks about clean code is probably Uncle Bob, which is and this is, by the way, I heard a lot more quotes from him, but this is the quote that I actually managed to find, and he actually says that the tests are actually more important than the code, because if the tests are bad, then basically that's it. You cannot add any more. So before we talk about everything and anything that I'll have to offer you here, there is a big question: is what is good? Because we are as engineers, we can argue all day what is good, and the other guy has something also good, and there is no absolute good, because something can work perfectly on one system or in one approach, and when you try to put it in another place, it's terrible. So good is an answer of it's just answering a few questions, and the question is that I'm usually asking if I want to declare what is good in this area is how easy to extend the code that you wrote. If for example you have a system and every time someone comes to you and tell you, okay, I need this new thing, and you tell him, okay, it's going to take me 5 months, then it's not so good, because systems need to change, need to add more and more feature because they're growing. And if you get to a design where everything you need to add it takes you a very long time to do so, then something is wrong. Another question is, if something is broken, how easy is it for you to fix it? If the system, if you added a new feature, if something is broken in production, if something happens to the system and it's broken, how easy is it for you to fix it? I see there are a lot of Army people. I think the phrase in the Army is MTBF, mean time between failures. You probably, from the smiles, I know that some of you at least know it. But again, if you write a system and it's broken and something is wrong and it takes you 5 days to figure out why it's broken, then it's also like a bad signal. And as an engineer, every time you get to a new system, the first thing that everybody wants to do is rewrite it. It's like, it's the ultimate truth. The last person who wrote it was an idiot. I need to rewrite everything. Sometimes it's true. Sometimes it's true. I'm not going to argue about that. But if your system, if the people who are working on your system always want to rewrite it, then then you did also something wrong. So those 3 points are just like questions, because again, if some of them are failing consistently, then you probably fucked up in some way. But so today we're going to talk about clean tests, and we're going to review some things about the test structure. We're going to look at like some new tests. We're going to have some live coding. By the way, how many Java developers are here? Scala? Okay. No, JavaScript, Node. Oh, okay. So by the way, I'm a Node programmer now. Although I programmed a long time in Scala in Wix, and actually everything that I'm going to show in the live coding here is going to be in Scala. But I actually do all of those things in JavaScript, although even that it's JavaScript. And so let's start. Okay, so the first thing that we can talk when we're looking at tests is the test structure. Why am I talking about test structure? Because test structure is the first thing that you see when you get to look at a new code. And when I think about structure in a concept of maps, or this is like the best example I can find, is, for example, Google Maps. Google Maps, the closer you get to the map, the more details the map reveals. And it depends on the zoom level that you're looking at the map to understand, so you can understand what exactly are you looking at. And the reason that they do that is basically the same reason that we're looking at code or any code or any test. If you have a good, if the structure revealed the right amount of details, then it's going to be easier for you to get into. But it's also like the preview to your code. So if someone sees the code and knows what to expect that will happen in each part, it's going to be easier for him to get in and read that code. So the first statement I need to say here is that the tests need to reveal really the right amount of detail. And the right amount of detail we'll discuss a little bit further on what I think is right. But the right amount of detail is telling you exactly what you need in each level. Another thing that we should that I want to point out as a comment here, that if you have a certain structure, try to be consistent, because every time you go to a new system and it has a specific structure or anything, and then someone else comes there, and then he decides that the previous guy was an idiot and is going to change the whole thing, and then another guy comes there and changes the whole thing, and then when someone goes to maintain that system, it's going to be very difficult for him to know which guy was. Well, he'll decide everybody before him was an idiot and write something new. But when you come to a new code and it has a certain structure, try to be consistent across the board. It's going to help everybody. Although this recommendation is bound to fail because things change. So just keep that in mind. I'm going to give you some tips, and some of you will come from like various systems. The question that you need to ask yourself in some areas is, I know I want to do something which is better, but sometimes if the system is written in a certain way, you might try to at least match yourself to the previous approach, or maybe actually rewrite everything back, which is my personal favorite, but well, I have too much time on my hands at times. So let's see, like, what is the right amount of detail? What are we testing? It's like, at first when we write the code, it's very explicit, it's very verbose. It's on the left side of the, and it shows a lot of details. We'll take a look at examples, and hopefully you can and you can understand, and you can look at the code and see that, but it has a lot of details. It gives you everything in the mechanic. And this is where the code is at the beginning. But you want to go a little bit deeper. You want to go on the bar a little bit, go to the right, and to express more of the behavior that you're testing. The more you test the behavior, then the more it's going to be easier for someone to understand what that piece of code does. And the question that you need to ask yourself is that, can a test stand on its own? Can you look at a single test case, just that test case, without the whole class, without the whole describe and everything, and just look at that piece of code and ask yourself if you can understand it. If you can understand it by its own and not drill down to 50 more lines of code and read a bunch of documentation, then you're in a good place. And this is the question that I keep asking myself while I'm processing and I'm refactoring the test. And on the flip side is when you try to refactor, you over-refactor a code, it gets to be very, very generic. And then you hide too much details, and someone who looks at it, and I'll show example further down the line, but if you refactor too much, you'll get to the wrong side of it and have that test so like generic. I know I can think of one example. If everybody saw like a test that someone writes a generic function that tests some functionality, and then it calls it in 5 different test cases with different parameters. So if you look at that test and you go like test something with 5, 6, 7, and 8, and then you look at it and you go like, okay, so what's going on? And then when you drill down into that function of test, you get like a bunch of generics and a lot of details there. And then you look at it and you don't understand how it's related to the code behavior. So this is an example of someone who's tried to over-refactor stuff. And by the way, there are ways to handle that specific case in a better way. But if you do something like that and someone needs to add a new thing to that test, it's going to be very, very difficult for him. So I talked so much about test structure, but let's look at a little bit of code. This is actually not my code. This is I changed it just a little bit, but this is from Guava. I looked for just a single test. What you see here is just testing that a future that is canceled, if you're going to call get on it, it's going to throw an exception, and if it doesn't throw an exception, it's going to throw an error. But I want to talk about the structure of that test, from what that test is built on. The first thing that you might see is a description. This description is very coherent, not. Test, cancel, not done, interrupt. Everybody can read that. The second part is the given part. This is where you do this test setup. You define a new future instance, and then you set it to be canceled. The when part is what the action that you're doing on the test. This is future.get. And the then is where you validate that the exception is thrown. The reason that I took a code that I didn't write, and the reason that I'm showing you that structure is because basically most of I guess that most of your test cases are divided into those sections. Unless you're doing something that is, some people try to over-test on a specific test case, then they do one action and validates it, and then do another action and then validates it again, and do another action and validates it again. And this is usually not a good pattern, but most of the tests that I saw are usually stick down to this structure. Any questions so far, by the way?
Can you explain about the future? For people who don't know.
The future is just a concept of having an operation that's gonna give you a result not immediately, but in a future time. But it's not even related to this. It's just I could might as well check a different. But
Future.get as thing that will throw an exception if everything works right.
It's like Ajax. It's like a future.
it's basically every I/O operation is you won't get the results back. But like I said, it's not. We can talk later on, but it's not even related to this. So let's start by writing a new test. The first thing that you see is basically the test description. In the tips that I can give you here is, first of all, don't write what they wrote because it doesn't make any sense. Use plain English. First of all, use English because when I was in the army, we wrote every variable like in the Oracle database that we had. Everything was a variation of Hebrew in English letters, and yeah, the table was pla pla peula. And well, maybe in the army they won't give it to anybody else, but most of the people here have colleagues over the sea, and if they don't have them, I hope for you that your company will succeed and you'll open more centers. But if someone will go to that Hebrew word or Ukrainian or Russian or whatever, or in this case engineering language, then nobody would know what the hell you wrote. So first of all, use English, and second of all, use plain English. Explain it like you explain it to someone like a 5-year-old. Yeah, that's a think when you explain it like you explain it to a new server guy or a client guy. The only tip here that I can give you is just find a structure and stick to it. That's it. Because first of all, it's very difficult. I think the most difficult part in our job is to find variable names and to describe stuff in English. But like I said, try to find a pattern and stick to it. That's the only good advice I can give you here. And with everything I said about test description, just remember one thing. Test description does not compile. So you wrote a lot of nice things, and then someone adds a new feature to the code, and then he changed the description. Well, he doesn't, and he never does. You don't, and so first of all, you write the test description, and it's good. So some people say, okay, so the test description is good. I don't need to refactor anything. It's like it's coherent. Everybody can read the description, and everything is good. But no, because sometimes some people, myself included, will just take a different test case and duplicate it and just change the content in the middle, or write something that's not correct, or change the code behavior entirely, and nothing will tell them that they're wrong. So test description, while is very good, it's not going to save you. It's a good start. It's a good start, and actually it's a good start, and it's a good start for you, so you'll know what you're planning to do. Just do it when the test description. You know, like what you're testing. And not just like roaming around and trying to think what you're going to test next. So it's going to focus you while you write the first test case. But again, it doesn't compile, and if it changes, that's it. It changes, and the test description is going to remain the same forever. On the next slides, I'm going to do some live coding, but I'll just explain what the test code does. It's a very simple scenario. You call an API on a server. It's gonna invoke. It's gonna take something from the database and invoke a send mail on the other server. This is the whole test case. Let's see if the tests are passing. let's test them again. So, by the way, you can see the code, or
Can you kill the light that's to your right?
that light, I think. Yeah.
Oh, it's me?
No. Yeah. The light is next to you, man. It's not.
Can you make the fonts, maybe kick the font size up one?
Can you invert the entire colors of the screen?
Stay on one font.
Yeah.
I mean, we already have this beautiful place enough now.
I agree, but unfortunately,
Oh, so let's.
We're gonna try to change that.
So this is going to be the example. It's very simple. I just wrote it specifically for this lecture, and this is what we're gonna test this on the rolling example. So let's start with the most interesting part. We have a test. Well, we have a couple of test cases, if you can see. This is Scala, so don't be afraid. I can do like a so the JavaScript people will feel better. But imagine it's there. This is the test case. There are a couple of them here. And sorry?
What's DAO?
DAO. It's going to take something from the database. There is a database here. There's always has to be a database. The gods demands it.
This is there's one guy.
Yeah, but he still demands it.
So, what is the process they're going to do when we refactor the setup thing? At first, we're going to extract some methods. Like we'll try to extract some method and try to see how we do it. Like I'll try to give a few tips on it. Then we're going to simplify the code, and then we'll extract it outside. Those are the stages that we're going to try to follow here. Let's start with the first one. Let's try to extract the methods. So if you can see here, site DAO get owner 4 returns none. Is this one? First of all, anybody thinks that this one is readable enough and we can go home, or it's like, can you look at it and understand exactly what it does?
Well, first of all, that line 42 runs off the end of the screen, so that the first thing I would do is break that line in half.
It's solid. We're not necessarily allowed to do that.
We have very wide screen these days. I don't understand. You're the 80 character guy?
We rotate our screens top to bottom.
Oh, we just rotate one of them. So anyway, this is like one of the test cases. This is another one. Anybody thinks that it's good enough and we can go home, or we're going to try to do? Yeah, I tried. I wanted to go home, but we're going to have to push.
Code in a language I don't know that fast.
So let's try to make it readable even for. First one is actually we're defining a mock. This is specs2 in Scala. Don't get dwelled on the details. But at first, when you look at it, you see how we do stuff. We know that we go to site DAO, we call some API with some variable, and it returns none. None is
This is a mocker.
This is a syntactic sugar that Scala gives us. It allows us to write it like this instead of using a lot of brackets and dots.
But this is the mock.
Yeah, the mock itself is here. You see, this is where I define the mock, and this is where I define the behavior of the mock.
But we're saying that this site has no owner.
I'm sorry?
We're saying that this site has no owner.
We're saying it doesn't.
Basically, yes. We're saying this site has no owner, but we have too many words here. So let's first take that and extract it. The first stage that I do is that I go to site DAO and I call the method def given. The reason that I'm giving here the given part is I want to imply the structure to anybody who reads that he'll know exactly that this is the structure that I picked. So using a given a name actually gives some more insights for someone about the test structure that you're going to take. We're going to say that site ID returns, and this is the owner. And we know that this is site ID, and let's return owner ID here. And so the first thing that we, just right off the bat, we wrote this. And now we have just like one method that tells us a story, but it still shows too much details. We have this none here, and we have the, well, site ID is okay. We can try to make it as a sentence. So let's say that we can change a little bit the method name, and we'll call it with. And the first step that the first thing that we want to describe is we want to get rid, like this none here is not really important, because this is what actually this is how we represent the way that there is no owner. So let's change this. Let's change this method to say exactly what we wanted to say. We want to say that given a site DAO without site, without owner, for site ID. And now when we write this like this, we got rid of that none. We're simplifying the code in a way that actually tells us what the meaning is. The meaning here is that we're trying to say that the site doesn't have an owner ID. But now when you write it, when you read that specific sentence, you know exactly what the behavior that you defined. And this is the more important part. On another area is like if we wanted to simplify that one that has an owner, and we started, so we'll start with the first method by saying this is site ID and this is owner ID. So if you can see right off the bat, we got rid of all the Mockito definition and stuff like that that is not very important for the test. This is very strict on the implementation. But now when we look at something like this, we can simplify that sum because we don't want to see it. The first thing that we want to do is actually when someone reads a sentence or when you tell a story, usually people are going to say, just get to the point. So the point here is that the site DAO is, what's important here is the owner ID. So let's switch the parameter order and allow people. I deleted something. Yeah, the ID sucks. So
part of me is just looking at this and going, why can't you do 80% of this in the type system?
you can, but well, I like to write usage to key. There are refactoring in IntelliJ. They're not that good. If you are coding in JavaScript, you would see that it gets worse in other languages, but
that's why I code in strictly typed languages.
It's very strictly
I was
typed.
going to say, I mean, it seems like some of the stuff that you're writing tests for, you shouldn't have to write a test for, because you can write.
No. But I'm defining behavior with mocks and other collaborator. I have to write that as well. This is not where type-driven development will help you. But anyway, the first thing that I want to do when I look at this second part of this code is that I want to get rid of this owner ID, and I can actually, by the way, the other test actually has the same logic here. And I want to get rid of, first of all, I want to get rid of the sum because it's not very important. There is always that value. So let's drop this here. and just move that logic into the method. And another thing is that we can do is we can actually change in Scala you can use right now in Java you can IntelliJ will show you the named parameters, but in Scala they're actually part of the language, so we can use them to actually signal what is the value that is interesting for us, which is the owner ID, and what is the part that is part of the key. So we can do something like for site ID, and then we can actually explicitly write it here. And this is one of the methods that I'm using to actually signal you what is the important part in this method, which is the owner ID, and what is the key that we retrieve it. It's very, for example, in this system is just a single string, but in other system where the key is composed of 3 or 4 values, then it's going to be more difficult for someone to understand that this is the whole key. So we can actually have like another variable saying and I don't know, and UUID, and when you see that someone use verbose parameters like this, it can actually signal you that something that those things are connected with each other. One thing that I'm not sure I mentioned enough is we can hide some of the logic from the test. Like, for example, I saved that sum, but usually you get methods that has lists on them. So you'll have a method that says, for example, list of something, or if you're writing Java, then mutable, whatever. Then the creation of that list is also in the test, and you want to save less and less words. So this is the part where you simplify stuff. So you can use var args instead of using a list. You can move some of that logic that creates the list inside of the test. And by the way, I didn't hear a single question that I was expecting here. Some people usually ask, but when you refactor the code, won't you break the test while you refactor it? If you wrote good enough tests and good enough code, then if you broke the test, then the code, the production code, will break the test for you. So if you're trying to validate something and the logic that you're using to validate it will break, then also the test will break again. So this is the first part. Let's try to recap on some of the things that we did here. We took the method name and we used the structure to imply what we're doing. We described the behavior. For example, we said that the site doesn't have a site ID, and instead of just explicitly returning the value. We reversed the parameter value, the parameter order according to the importance. Usually it's the opposite of what the code was calling. And with parameter names, we try to imply what is more important and what is the key that we're using to retrieve it. Any questions so far? Cool. One point that I'm trying to make is every time we're trying, on every step, we're trying to describe what we're testing, what the code does, and not how we do it. For example, where we said that the site doesn't have, that we don't have a site for that specific owner ID, then in Scala we represented it as a none. But if we were using, usually in Java, maybe now with optional, but it could be null, and maybe if you are working C style, then when you call that specific collaborator, get the user ID and it will return -1, then you know that the user doesn't exist. So the behavior itself shouldn't change. The implementation will change later on. So and this is what we're trying to do on every step of the way. We're trying to describe what we're doing and not how we do that. So in this section, when we look at the mock, then the mock is how we do that, how we do each stuff. But basically, we're trying to describe the behavior. The good thing about behavior is that behavior doesn't change that much. We can actually change. We can actually change the code. We can change some of the contracts inside it and still not touch the test. The second step is to simplify the code. So first of all is do not use concrete values in the tests. I'm sorry?
Dijkstra has a word for it. It's naked.
Naked, okay.
Concrete.
Naked is, okay.
We don't want to be naked.
You don't want to use explicit values in the test. And if you're, for example, I myself, I like to use random values, but this is only my personal taste. Some people, like, if you can see, I already did that because, for example, user email, some email at example.com is the email that I chose, and I called it just user email. The reason that I'm putting it into a variable and not using it explicitly in the test is because if you write, like for example, I can describe a very common use case. Someone writes an email, admin@wix.com, or something that is important for a specific test, and then when someone reads it, he doesn't know if admin is important. Maybe it's important, maybe it's not important. But if you pack it into a variable and describe what the variable contains, for example, I could call it user email, but I could call it some user email, or random user email, or anything else, to imply that to anybody who reads that code that specific value it's not important. And for example, if you'll have someone writing a code that actually needs the admin@wix.com, and then someone else want to use that variable in another test, and he goes, oh, it's an email, and he used that, and in the other test case, admin@wix.com is not important at all. And what he did is just copy-paste it from one place to another, and that's it. That on the other test case, some people may think that it's important. Oh. Another thing that we did also, we reduced the number of moving parts. We stripped down the list, we stripped down the sum and the optional. The way that we do that, when we do that, we take out some of the complexity from the tests and from the code that people are looking at. At first it looks like a list, and if you're writing Java, then sometimes you know how to, I don't know, look at a code and just look at inner and ignore some of the things. But if you actually look at a code and have, when you look at this code and it doesn't have any words in it saying some list or sequence or everything, it actually reduces the burden of someone reading that test to understand what's going on. So less is more in this case. Okay. Firefox keep crashing on me. And the last step on this section is, this part is, I'll try to give an example. Like the example is, for every test case, you defined that the site has an owner, that there is a site for that specific owner ID. And then someone looks at it and goes like, oh, I have 5 test cases, all of them define the behavior. Let's take it out and put it on the before part, or just call it outside of the test. What will happen in this case is that if we remove that, if we take out this sentence outside of the test scope, and first of all, it will break the first rule that I try to say here, is that someone who reads it won't know where the site came from. So in this case, if you over-refactor stuff, then it's going to make things less coherent for someone else. So try not to move anything of the setup outside of the test scope. The only things that I think that should be outside of the test scope usually is environment setup, I don't know, define some config or start the database or start something. But if it's important for the test, it has to be there. The last part is to actually try to extract drivers from it. So if we're using, I'm using usually the same, I'm extracting an external site DAO test support, that's the name. I'm gonna do some things that are needed here, but ignore it. This is something that I have to do because of specs, so ignore it. But what I'm going to do here is I'm going to rip it out of that specific scope that defined the whole test. And so I'm going to put everything inside an external trait. And I'm also going to take all of the variables that are needed, that are used there. This is site DAO, so I'll take the site ID out of it. And now this specific, now I have a smaller entity that manages that specific concern. If I would have refactored the user's DAO as well, I would have extracted everything out of it into another trait. The reason that I'm doing it is, first of all, now when all of that is out of this trait, it's less setup. And another thing that is, when you look at this specific piece of code, you know what the behaviors that you're using with that specific collaborator. It will give you a lot of insights. But also, everything that's related to sites DAO sits just on one place. And usually, I actually take that trait out of that test case, because it's not important for someone to understand the test. So everybody who look at the test now wants to see something like that. He knows what the behavior that there is on the test. It doesn't need to see the implementation. And if he needs to see that implementation, he can drill down. I keep doing this, but so we moved to extract everything. We moved all the setup method, all the related variables to it, and we split stuff according to the subject. It makes things clearer when you try to read the test as a whole. And the workflow was very simple. We extracted the setup method, we simplified the code a little bit, and then we extracted drivers out of it. And if you notice, it's kind of a circle, because every time you do something, at first you extract the method, and then you see that you can simplify stuff. So you keep on doing it in a loop until you find something that makes sense to you. This process doesn't have to be just a one thing. I showed it as a whole, but to me, it was a very learning in progress, in which every time I said like, okay, I'm going to first extract the method, then I said like, okay, this variable and this variable. So the simplification and everything is done in stages, and it's going to help you to do that. The more every step that you'll do, the next step will come and arise. One thing that people, when they see that, they go like, oh, that's premature. That's a premature optimization. Why are you doing it now? The reason that I'm saying that you should do it now is because you extract stuff into smaller pieces. But if, for example, we wouldn't do the step where we extracted the driver, because, well, it's just like 5 lines or 6 lines. The problem is that when you write code as at first it's very little, it's very small. It has like 5 or 6 lines. It has a very a single subject, and it's very. In this test case, we'll have users and site DAO, users DAO and sites DAO, and that's it. They have only like 2 setup method. It's 6 lines. There's no need to actually extract them. But what happens with code? Code usually changes. So the next guy that will need to do stuff will go and add another method, and add another method, and add another method. And once that code will grow more and more, then before you notice, it begins to be gigantic. So, and then when you look at it, you go like, would I refactor it? No, it's too big now. So I'm not going to touch it. I'm not going to risk it. So start early. Start when it's still manageable, because if you don't start early, it's going to be very late, very, very soon. Any questions so far? Oh, not a lot of questions. Oh, yes?
I have a question. How do you make sure that the test after refactoring is still strict enough and still testing the... So it would fail if the code actually broke.
So if I broke the test, if, for example, I did something wrong here, and instead of none, I would return, let's say, this, and I'll start and I'll try to run it. Now the code actually will validate it for me, because I wrote code that actually expects a specific behavior from the test. I broke the test, and now this test case is broken. And we'll talk about failures first.
In some cases, that's true. I mean, if you're passing in an incorrect value, that's true. But if you are asserting some expected value, and you refactor and factor it away the actual expectation.
Yeah. I think it means if you're relaxing the test.
Yeah.
If the test passes, relax the test and still pass. It might not fail.
Yeah, if you ruin the expectation, then yeah, this part you have to be extra careful.
You have to write failing code to test your test.
Or maybe
Yeah,
That's actually a good idea. Create a throwaway Git branch.
It's called mutation.
Yeah, no, but intentionally break your code and see if your test catches it.
There are, by the way, there are methods of like trying to break the code and see that the test. Sometimes, usually, when I writing the expectation part, and we'll get to it further down the line, is I actually break the code to validate that the expectations still work. And by the way, you'd be amazed how many problems you'll have because of that. Because I personally discovered a few times where the testing framework was not, had bugs in it and didn't test what I expected it to test. And by the way, this is part of the reason why test-driven is the preferred method in Wix. Because if you have a test that you think that should pass, but you never saw it break, this is what happens when people write tests after. They run the test and they go like, okay, it's passing, everything is good, but they forgot to see that they didn't actually test what they thought they were testing. But we'll get to it. We'll get to the expectation part a little bit further down the line. The next section is actually the simplest one, is writing the test action. What's happening? We set up everything, and now we want to test the behavior, the code itself. So in this case, in the previous case, it was future.get. I try to have just the action itself usually should be just one call. In this example, future.get. But sometimes it needs a little bit more than line, but usually it's going to be just one line. Try to make it like this. And another thing is, this is, by the way, a part of our code base. You see here recording studio.record. And if you see here the log event, this is someone who had a log that did a couple of stuff, and he didn't want to see them in the test case. So he wrote a method that does the logging for him. But when you look at this piece of code, some of you won't even understand what are you testing here. Are you testing the record method? Are you testing I would think that you're testing the record method, because someone hid and wrapped the test action. And in this case, it's going to be very difficult for someone who reads it. So try not to hide it. By the way, there are a few more issues with that test, but we'll get to them later on. And this is it. This is the whole, because there are not a lot of things that you need to do in this one. And the last one is the testing the expectation of you have from the code. That anybody familiar here with matchers? If there are Node people, then chai, right? And nobody uses chai here?
Yeah. What's the word matcher? How are you using it?
Matchers, how do you?
What's the chai line of code you would write?
Chai is a matching framework.
You say expect something to be a number.
Yeah, expect something to be a number. But one thing that is very easy in Scala is very easy to write the matchers. In Chai, it's a little bit more.
What do you mean by matcher? Because
Matcher.
those things I think varies, but terms that only happens in some languages.
It's like an assertion.
Okay, how is it
But it's
different?
not an assertion.
What?
But it's not an assertion.
No, it is.
It is an assertion. It's just an assertion framework. It's an assertion framework that allows you to express your intention in a better way. Okay, it allows you to reuse stuff. If you write matchers, then you can compose them later on. But a good matching framework.
Like, what would a good matcher, like, what's a definitive assert? This is an integer or?
This is an good question, but let me. The reason that I'm saying as a matching framework, it allows you to write what you're expecting. But what I'm saying is, if you write your own matcher or your own validation, for example, in this case, I wrote my own custom matcher that checks that it matches some expectation. For example, be a teenager implementation should be probably the age is lower than 20? I would say 16. 13 to 19. So if you'll have an assertion, usually you used to having assertion saying age is bigger than 13 and smaller than 19. This is the very implementation of how to understand that this is a teenager. So this is what happens when you assert stuff. But if you write a matcher that expresses the behavior, then you can just write that it's a teenager. And for example, there are matchers that use custom built-in structures, like be none in Scala. But you can actually write your own custom matcher and say that in this context, be none is user doesn't have a site. So this is like the first one that we can talk about here. The second one is that I mentioned it earlier, is use just one matcher or try to compose a few matchers. Like in this case, someone would assert that the user has age between those ages, and also the location is USA. So why not say it in just one sentence? So if you try to write just a single matcher that expresses the behavior, it's going to be easier for someone to know what you're matching. Because if you see those three details saying this and that and this, and then it's going to be very difficult for someone to understand what you try to say. And this is the example, the last example. It's like the Be American teenager is actually those three built-in matchers. It's bigger than 13, it's smaller than 18, and it's also location is USA. But I'm describing how I'm testing stuff. It's going to be very difficult for you to see what my meaning is. So if you write stuff, if you write them in this way, it's going to be easier for someone to know what the behavior that you're testing is. What behavior do you expect when you run the code? Another thing is, when you define new variable or you introduce new variables to the test, If we will look at the sections, then we'll have the given, the when, and the then. So in the given, we usually introduced most of the variables to the test. When we use the when, usually the only variables that we can represent there is concrete values usually. You're querying a specific query, or this is like another variable. But what I want to say in this slide is never ever add variables that match against variables that you didn't define in the previous stages. It's, for example, the log event test that I showed you earlier. I'm going the wrong way. This one. If you can see, he matches a few variables on the end of the test. Bar is a tuple of bar and buzz and method and foo, but nobody actually understands where those values are coming from. So in this case, it's going to be very difficult for someone to understand what you're matching. So never match against something that you didn't add. It's only going to confuse someone further down the line. And as for, by the way, this is something that I try to do, but I also fail with that, is failure messages. When something fails, for example, this is actually one of my tests failing. And like I said, I like to use random values. And if you can see those publish requests, they're different. But it's going to be very difficult for anybody to understand what is different. So if your test is failing, when it's failing, try to make sense of it to see that when it fails, you know what failed. I can give when I was working in another company, we had a test suite that ran, that someone from, we had a team in India that was running them. Back in those days, I wasn't writing any tests. And one of the days I got an email saying that the test failed. One of the tests in the test suite that ran for 45 minutes was failing. Then immediately I asked for the logs, because this is what I used to understand what was failing. And then I got like 15 tera of logs, including the binaries of the system, with all of the tests that was being ran on the system for the last 3 months. So I had to dig through. And by the way, at the end, after like a week of going through and sorting through logs, I understood that the test wasn't testing anything, actually. The test wasn't, it was checking some variable that nobody actually touched, and by miraculous way, it was working, and everything was green. And then something changed in the system that the system, another millisecond, and that variable changed. And then from that time on, the test started to fail, because some of the timing in the system changed. So this is like one example of saying, when something breaks, it should break something really. But again, if it took me over a week to understand what broke in the system, in this case it didn't break, but that means that something is wrong with the test. So when tests fail, make sure they should fail, first of all. Some guy would appreciate it down the road, or curse you if you didn't. And make sure you know exactly what failed in the system. This part is actually kind of a blind spot, because you just see that the test is breaking and then you're continuing on. But make sure that when it breaks with a proper message. A proper message that someone, if the test breaks, knows what broke in the code. And I'll try to sum it up, and then if you have questions, then I'll be happy to answer them. What are the takeaways that we can take from this presentation? When you refactor stuff, try to refactor it that the test will show the behavior. And the way that you will do that is that you look at a test and you will try to understand the behavior from just looking at a test case and not everything else in the test. Another thing is start today, don't wait. If you wait, it's going to be too late, and it's going to be too late sooner than you realize that it happened. So try to do it as fast as you can at the minute you write the test. If you wait, then it's going to get too big, and then you will be afraid to risk it. Describe on each section what do you do and not how you do that. And always use what you defined. Never use something you didn't define in the test. And that's everything I have to say for today. Any questions?
Can we clap for you first?
I'm sorry? Thank you.
I have one. While you were refactoring the test, it became more Englishy.
Okay.
Besides for the spelling mistakes, which I'll forgive.
Never have any English-speaking people. Well, it wasn't Hebrew. I could write Hebrew, and then it was totally correct.
American, it was not Canadian.
Okay.
My question is, it's kind of with your scale that the spectrum you brought up earlier of hiding and showing, and as you make something more and more Englishy, the kind of the end of that spectrum is cucumber with these tests that can be legible to like a product developer. Where do you see, this is always the big problem, is with testing, where do you see the non-technical people in this, and how do you, how do they understand this?
So are you asking if we're able to write tests that actually product people can read?
Well, I'm not pushing you too far. But the question is kind of like, you're trying to make it legible for the next coder. So where's the balance of you're using your language feature, your language to actually write a test, and you're trying to make something really, really too simple?
Where do I know? How do I know that I went too far?
Yeah. How do you?
I think that this is one of like the questions that I said. If a test can stand on its own, if you can look just at the test, then you didn't went too far. Even though it's Englishy, notice that I even in the test that I wrote here, some of it is English, but I only took out the non-interest. You know what? Even in this one, there is mail server dot recorded must be empty. This is actually telling the meaning. If I would write a matcher that would express this, it's going to be mail server must not receive any mail. Okay, I always get it wrong.
It's French, you used to German words, that's why.
Any mails. So.
English doesn't borrow foreign languages. All the dark alleys at the open head throw much around their pockets.
So this you would call too far if you're writing a matcher for this?
No, I wouldn't call it too far. I would actually, this is actually how I write those tests. And the reason that it's not going too far is because I'm hiding only the implementation. Like in this case, you see that I wrote like a mail server, and it checks that it got any recorded request, and the way that I'm validating it is that I see that it's empty. But in other cases, I'm actually have like a matcher that checks that email. So that specific logic might confuse someone who's looking at it. So
like this is much less legible.
Exactly. The more details you have to read, the more words, the more variables, it's going to be difficult for the next guy. So I'm trying, as I'm refactoring the code, to make it more approachable for other developers. As for product people, I actually wrote some tests that I wrote it specifically so it was actually checking, validating the rating of an app. according to some of the questions. So I tried to write it in a way that he gave me the specification. So the test was expressing the specification that he wrote. And I worked very hard to make it readable for him. He never read it though, but it didn't keep me from doing that. But
so the answer is there's kind of not really so much an upper limit of Englishiness.
no, I wouldn't say there is. Any more questions? If there are more questions, I'll be walking around here later on. Thank you very much for listening. Hope you got it.